This is number 8 from part 2 of the practice test. It is one of these problems where it gives us position and asks us questions about velocity or acceleration. So part A wants the velocity with which the particle travels at 4.5 seconds. And we are given the position of the function. The easiest way to do it would be to graph position. So velocity is the derivative of position. So we can graph position. And then I want the derivative of this at 4.5 seconds. So calculate dy dx. At 4.5 seconds. And we get 5.261. So velocity at time 4.5 is 5.261. Another way you could do this one is actually find the derivative. You're going to need it later anyway. So I'll show you how to do that. So v of t, derivative of this part is -1/2. Derivative of this term. So I've got 3 times sine. 3 is a constant, so we don't have to use the product rule. Derivative of sine is cosine, so I have plus 3 cosine of 2t minus 3. Chain rule times the derivative of the inside, so times 2. So multiplying by 2 is going to give me a 6 out here. So that's velocity, and then you could plug 4.5 into that equation. And we get the same 5.261 we got when we graphed it. Part B wants to know, is the particle speeding up or slowing down at t equals 4.5 seconds? So we already know that the velocity is positive. V of 4.5 was positive. We need to know, is the acceleration positive or negative? So acceleration is the derivative of velocity. So again, you could do it one of 2 ways. You could either graph velocity and use dy dx on the calculator, or you could find the derivative by hand. Derivative of a constant is 0. Derivative of cosine is -sine. Times the derivative of the inside times 2. And I also had this 6. So 6 times the derivative of the inside is where that 12 comes from. And then plug in 4.5. So I get the acceleration at 4.5 to be 3.5353. So we had a positive velocity. We found that in part A. We have a positive acceleration. So if velocity and acceleration have the same sign, it is speeding up. Part C wants the average velocity with which the particle travels between 2 seconds and 10 seconds. Average velocity, so we're going to find a slope. If we're finding a slope, to get a velocity, we need to be finding the slope of position. So we need to plug in 2 and 10 into the original equation to get 2 positions, and then finding the slope of 2 positions will give us an average velocity. So we're plugging 2 in, and we're plugging it into position. And we're also plugging 10 into position. So plugging in 2 gives me 1.52441. Plugging in 10 gives me negative 7.88419. Should round to more than 3 decimals because that's not our final answer. So if you round to 3 decimals now, find the slope, and then round to 3 decimals again, it might be off by a little bit. So you don't have to use the big long decimal, but at least 4 or 5 would be good here. And then find the slope between those 2 points. So I have this number minus that number, and then divide by 8. And finally, part D. Part D wants us to find all times when the particle changes direction over the first 3 seconds. So if the particle's moving this way, it has a positive velocity. And if it's moving this way, it has a negative velocity. So what we want to do is we want to find when does the velocity change from positive to negative, or when does it change from negative to positive. That is when it would change direction. So we are going to graph the velocity equation, which we found back here. There's our velocity equation. And we only care about the times over the first 3 seconds. So from 0 to 3, if you want to change your window, that might not be a bad idea. I go from -1 to 4. So from 0 to 3, this is velocity. We want to know when does velocity change from positive to negative or negative to positive. So the velocity, this is a graph of the velocity. So the velocity is negative because it's below the x-axis, and now it's positive because it's above the x-axis. So we want to find this point right here. So we can calculate the 0 in between 0 and 1. So v of t changes sign. That's what we're looking for. And then list the times at t equals 0.756. And we have another one right here where it changes from positive to negative. Looks like we have another one over here by 4, but remember, we only care from 0 to 3. So this other one's in between 2 and 3. 2.244.